Hello students. So today we are going to understand how you find a solution to a non-exact equations. In my last video, I have taught you how to find solutions for the exact equations, right? So some of the equations you can guess they will not be exact. Okay. So what we do, for example, let's take an example of non-exact equations, right? Just to revise. So let me take the example y dx plus x square y minus x dy, right? So to find whether this equation is exact or non-exact, what you do, you compare it with m dx plus n dy equal to 0, right? And then you find whether del m by del y is equal to del m by del x, okay? Let's find this. So as you can see, del m by del y is what? 1, right? And del n by del x, you can see 2xy minus 1. And they are not equal. So that's how we define exact equations. So this given equation, given differential equation is non-exact. Okay. So what we do, we will try to make it exact. Okay. For that, you multiply with some factor. Let's multiply with a factor of 1 by x square. So given equation, as you can see, okay. So this is the given equation, okay, and I'm multiplying with 1 by x square. What will you get? Tell me. Y by x square dx plus y minus x upon x square into dy, right? I should cut it and I can directly write it here. Y minus 1 by x, okay? Y minus 1 by x is equal to 0. Now, when you will find this del m by del y and they will be equal. You can quickly check. Okay. So let's check it. So what would be del m by del y? As you can see, it is 1 by x square. And what is del n by del x? This becomes 0, right? And here minus 1 by x, if you differentiate it with respect to x, you will get 1 by x square. So now you have the exact equation. Now you have two options. Follow my previous video to find the solution, or sometimes after multiplying with some factor, this equation will be so obvious you can easily tell. And by obvious, I meant something like this, right? X dx plus y dy. Sorry, x dy plus y dx is equal to 0. All right. Now, if this equation is so obvious, you can easily find this, easily convert this equation into this. And so your solution to the differential equation would be this. Xy equal to c is the family of curve. Okay. Now, the thing is, not every time you can guess what you are going to multiply it with. Okay. So the factor that you multiply, let me call it mu. It can be a function of x and y. It can be a function of x. It can be a function of y alone or both. Okay. So it is a, you can easily prove it. I'm not going to prove. Let's call it a theorem or whatever you may want to call it. If so, but remember, you have to remember this. If a general solution exists, a general solution exists for what? For given differential equation. Okay. For given differential equation. Okay. Then there will always be a factor. Then, and that factor we are calling mu xy. Then mu xy will exist. You just have to find it, will exist. And this corollary, you can prove this also. You can comment under the video if you want a proof for this particular corollary, or you can say theorem or whatever. Okay. But I'm not going to prove it here. But if a general solution exists, then you can easily find a factor. That could be a function of x, y both. That could be a function of x alone. That could be a function of y alone. Okay. Now let's continue. So we have to have some, proper method to find this factor. And this is the factor, you call it integrating factor. Okay. Integrating factor. Okay. Remember, we are still doing first order differential equation, first order ODEs. Okay. Now, how are you going to find this mu? Tell me one thing. So far, whatever I have taught you is this. If m dx plus n dy is equal to 0 is not an exact equation, non-exact. Okay. If it is non-exact, then what I told you to do? I told you to multiply with mu. Okay. Mu n dy is equal to 0, right? Now, once you multiply it with mu, this becomes exact equation. Okay. Once you have the exact equation, follow my previous video. Okay. If or follow my previous video, what I mean is follow the method or steps that I taught you for exact differential equations. Okay. But here my purpose is to find mu. Okay. Now tell me one thing. In my last video, when I taught you, if you are given a exact differential equation, how will you check? You will check partial derivative of this. Now m is not alone. Mu m, the coefficient of dx with respect to y is equal to del of n, and n is now mu into n upon del of x. Okay. Since you already know that it is an exact equation, I'm going to use that fact to find mu. Okay. How would I do it? Let me show you step by step. Okay. Now, mu can be a function of xy. It can be a function of xy both or alone. Okay. So you apply product here. So it could be mu del partial m of partial y plus m, right? Partial mu of partial y, right? Is equal to mu partial n by partial x plus what? N, okay, n partial mu of partial x. Am I right? Okay, let me just check in my notes. Okay, fine. I'm right. Now, what I want from you is collect the mu part. Okay, take this term and this term together and the others together. Okay. So when you will take them together, what will you have? Del m by del y minus del n by del x is equal to n del mu by del x minus m del mu by del y. All right. Now, what I want is I want to write it like this. This is to prove something, right? Not to prove, rather, you how you find mu. Okay. You will see how. Minus m del mu by del y is equal to, I have just taken mu on the right hand side and I have written everything on the left. And so what you are left with on the other side, del m by del y minus del n by del s. Okay, now let's assume for a while mu is not a function of xy both, rather mu is only a function of x. Okay, if that is the case, this part will go away. Del mu by del y will be 0, and this partial del mu by del x will become full derivative d mu by dx into n into 1 by mu is equal to del m by del y minus del n by del x. All right. Now you can easily find mu from here. D mu by dx is equal to del m by del y, sorry, minus del n by del x upon n. Okay. Now remember this. Okay. Now okay, let me just conclude here. This left hand side, whatever you have written on the left hand side, okay, if this is a function of x only, since, tell me one thing, if right hand, sorry, if, okay, that's right hand side. Tell me one thing, if left hand side is a function of x only, right? How can right hand side be a function of y? No, right? So if left hand side is a function of x, right hand side has to be function of x. Let's call it gx, okay? And from here, you can easily get d mu by mu into gx dx. What would be mu? E to the power gx dx. Okay, this is the integrating factor that you need to find out. Now, in every given non-exact equation, you can easily find this. M would be given, N would be given. You just have to find this value. Okay, you have to remember this, or you can just follow the steps and do it. Okay. Now, this becomes the integrating factor. Okay. Similarly, when mu is a function of y only, right? If mu is a function of y only, where it is, okay, yeah, here only. In this equation, if mu is a function of y only, this will go away, right? And you will have this. Remember, I'm just not going to do it again. I'm taking minus m on the other side, and rest would be same. Now, this equation will have another form. Okay. Uh, let me take green. Okay. What form that equation is going to have? D mu upon, sorry, dy 1 by mu is equal to del m by del y minus del n by del x upon what? Minus m. I told you, right? So you remember this. Now tell me one thing. If right hand side is a function of, sorry, if left hand side is a function of y only, right hand side has to be a function of y. Let's call it gy. Okay. Again, you can find from here mu e to the power gy dy. Okay. Again, you have integrating factor. Okay. So similarly, you can find integrating factor if it is a function of x, if it is a function of y. So first you have to check. Okay. Now let's close this video by just verifying whether this method works or not. So in the beginning, what equation I had taken? This, right? And I had shown you that its integrating factor is 1 by x square. So let's check whether its integrating factor is actually 1 by x square or not. Okay. So I'm going to write down that equation again. It was y dx plus, what was it? Yx square, right? Yeah, x square y minus x dy is equal to 0. So let's compare it. M dx plus n dy is equal to 0. What you have to check? You have to check either del m by del y minus del n by del x upon n, right? Yeah, let's just verify. Yes, in first case, let's see if it is a function of x or y. So numerator is same for everything here. So this is 1 minus, this would be 2xy minus 1, right? Upon n is what? X square y minus x, okay? So this becomes 1 and plus 1, 2, right? So minus 2xy plus 2 upon, take x common. What are you left with? Xy minus 1. And in the top, what is it? Minus 2y. So take minus 2 common. What you will be left with? Xy minus 1 upon xy minus 1. This goes away. What did you get? Minus 2 by x. Basically, this value is a function of x only. What you got? Gx. Okay, some function. Now your integrating factor would be what? E to the power minus 2 by x dx. Gx dx, right? E to the power minus 2 ln x or 2 ln, sorry, e to the power ln x to the power minus 2. Whenever you write ln, that means base is e, and this you can easily write minus 2. So your integrating factor is 1 by x square, right? Once you multiply that equation with 1 by x square, you can easily find the solution. Okay. And how do you do that? I'm just going to write down the final answer here. All right. So once you multiply with that and you simplify, this is what you get. X squared dy, and just arrange the term, and minus x dy minus x dy minus y dx is equal to 0. You can easily write this thing as what? D of this thing. D of y by x is what? It is x dy minus y dx upon x square, right? And then this part you can replace it. Divide both sides by x square. What will you get? Y dy minus dy by x equal to 0, right? And then just integrate it. Once you integrate, what will you get? Y square by 2 minus y by x is equal to some constant. So this is going to be your solution. So here I took the advantage of some experience, or this this could be written in this form and you got the solution easily. If you don't know this, you can follow those steps I taught you in the last video for exact differential equation and do this question. Okay. Thank you so much for watching the video. Do subscribe to the channel.